Hi, Assalamualaikum and a very good morning. So now we are in chapter 10, which is carboxylic acid, and we're going to focus on the subtopic of 10.5, which is the chemical properties. In this video, we're going to look into the chemical properties of carboxylic acid, and we're going to explain that with the reaction using the neutralization with the base, reaction with positive metal, for example, sodium, magnesium, or calcium, reduction with lithium aluminum hydride followed by hydrolysis, acyl chloride formation, anhydride formation, esterification, and amide formation. So they're going to be 7 reactions altogether. Okay, and last but not least, we're going to explain the reducing property of the methanoic acid, where it's going to have both the properties of aldehyde and also carboxylic group, and it's going to react with the KMnO4 and tolerance reagent. So without any further ado, let us start. So for the reaction using carboxylic acid, we're going to deal with these 7 reactions. And the first 2 reactions here are going to involve the OH cleavage. So this is labeled by using A here. And the next 4 here going to be involving the substitution using OH group, and it is labeled using B. Meanwhile, for the third type of reaction, which is the reduction, it will only involve one example here. Okay, so total they're going to be 7 reaction, 2 for A, 4 for B, and 1 for C. Okay, so now let us look into the A part first. So the reaction that involves the OH cleavage is the neutralization reaction. So carboxylic acid are basically acidic, and it can react with a base such as the sodium hydroxide to give metal carboxylate salt. So let's say if we have a carboxylic acid react with the sodium hydroxide aqueous, what we're going to produce is a carboxylate ion and with a negative charge here. And the metal, which is the sodium, going to be close by to the negative charge. And this going to get a byproduct of water. So a specific example here, let's say if we have a benzoic acid react with a sodium hydroxide, what you're going to get is the benzoate ion with a negative charge here, and the sodium metal going to closely at the close vicinity to the carboxylate ion here. And this is known as the sodium benzoate. And the byproduct here going to be water. Now we move on to the second reaction of the A types, which is the reaction with the electropositive metal. So the example of the metals that we are using is sodium, potassium, calcium, magnesium, and even ferrum. So mostly the metals came from the group 1 and group 2 of the periodic table. So let's say if you have a carboxylic acid and then you're going to react that with a metal, what you're going to produce is a carboxylate ion, and the metal going to be close by with the carboxylate ion, the same as before. However, the byproduct here going to be water. Okay, just now the byproduct here going to be hydrogen gas. Just now the byproduct is going to be water because it uses sodium hydroxide. So OH here going to become water. Okay, so that's for that's for reaction 1. For reaction B, you're going to produce hydrogen gas. So example here, let's say we have the cyclopentane carboxylic acid react with a potassium metal, which is in group 1. What we're going to produce is a carboxylate ion with the metal attached to it. And the byproduct here going to be hydrogen gas. Next, we have a propanoic acid. So when we react with magnesium, which come from group 2 of the periodic table, what we're going to get is a carboxylate ion as well as the magnesium 2 plus. Okay, as what you can see here, the charge are not balanced. So what we're going to do, because the charge is not balanced, so what we're going to do is we're going to bracket all the carboxylate ion and bring it with the number 2 here at below, so that the charge is neutral, 2 minus and 2 plus here. Okay, and the byproduct here going to be the same as, which is the hydrogen gas. Okay, now we move on to the B type of the reaction, which is the reaction that involves substitution of the OH group. So first is the formation of the acid chloride. So acid chloride is prepared by the reaction of the carboxylic acid with thionyl chloride, which is SOCl2, or using PCl5, or using PCl3. So here is the reaction scheme. So if you're using SOCl2, your OH here going to be changed with Cl. And the byproduct here going to be sulfur dioxide and HCl. If you're using PCl, the same thing going to happen, but your byproduct here going to be POCl3 plus HCl. If you're using PCl3, you will still get acyl chloride, but your byproduct here going to be H3PO3. Okay, so your byproduct will be dependent on your reactant here. Okay, so now let us look into the specific example here. So let's say if you have SOCl2, then your OH is going to be changed into Cl, and your byproduct going to be sulfur dioxide and HCl. Okay, the same goes to PCl5. So you change it with Cl, and your byproduct here going to be POCl3 plus HCl. And if you're using PCl3, the same thing, but your byproduct going to be H3PO3. Okay, now we move on to the next reaction, which is the formation of ester. So carboxylic acid will react with alcohol in the presence of the mineral acid catalyst, which is H2SO4, in order to produce ester. Okay, so the general reaction here is we have the carboxylic acid, and then we're going to react that with an alcohol in the presence of the acid catalyst. So it can be any kind of acid, and then what we're going to produce is an ester. Okay, so the H going to be removed from the alcohol, and OH going to be removed from the carboxylic acid. So the byproduct of the reaction going to be water. And then let us look into the specific example here. So let's say if we have the propanoic acid, and then we're going to react that with ethanol. So what you're going to do is you're going to remove H from the alcohol and OH from the carboxylic group. Okay, so what you're going to do is you're going to link the acid and alcohol group together in the presence of acid catalyst, and what you're going to get is the ethyl propanoate. Okay, and remember, do the naming from alcohol first, which is ethanol become ethyl, and the carboxylic part gonna be oic acid, you change it into OATE, so it's gonna be ethyl propanoate. Okay, and the byproduct here gonna be water. Okay, so similar to here, which is ethanoic acid, and then you react that with methanol. So what you're going to do is you're going to remove hydrogen and OH from here. So the byproduct that you will be getting under the presence of acid catalyst is going to be methyl ethanoate. Okay, and the byproduct here going to be water. Now we move on to the next reaction, which is the formation of the acid anhydride. So acid anhydride are prepared from the carboxylic acid by removal of the water molecule through heating. Okay, so this is known as the dehydration reaction because you are removing water molecule. So let's say if you have a carboxylic acid here and you react that with another carboxylic acid. So what you're going to do here is that you're going to remove OH and hydrogen here. So you're going to remove water, and then you're going to link the carbon and oxygen here. So this is why the red color bond is forming, because the carbon and oxygen here are going to link together. Okay, and the byproduct here going to be water. Okay, and this structure here is known as anhydride. Okay, and this must happen using a P2O5, which refers to a phosphorus pentoxide at high temperature. Okay, now let us look into specific example. So one carboxylic acid here, which is the ethanoic acid, react with another acid here. So at the presence of P2O5, which is the phosphorus pentoxide at high temperature, what you're going to do is you're going to remove the OH as well as the hydrogen here. Okay, so this is going to remove H2O, And then the oxygen and carbon gonna link together to be something like this. So this is known as the anhydride. And then the byproduct gonna be water. So similarly, if you have the this structure here, which is the benzoic, the 1,4,4-methyl benzoic acid, reacting with another carboxylic acid here. So what you're going to do is you're going to remove OH and hydrogen in the presence of phosphorus pentoxide at high temperature. So what you're going to do is you're going to link oxygen and carbon here. Okay, and this is known as anhydride as well. And the byproduct here going to be water. Similarly, for the acid anhydride to be formed, you can also react carboxylic acid with acyl chloride. Okay, just now is carboxylic acid with carboxylic acid. Now is carboxylic acid with acyl chloride, but in the presence of pyridine. So carboxylic acid react with acyl chloride. Okay, so instead of using OH, we're using chlorine here, which is acyl chloride. So what we're gonna remove is HCl. Okay, so in the presence of pyridine, HCl gonna be removed, and the carbon here gonna link a bond. Okay, and this is known as the anhydride. The byproduct gonna be HCl because HCl is being removed. So let's say if you have a carboxylic acid here, which is the ethanoic acid, okay, react with the chloroethanoic acid. So what you're going to do is you remove your HCl here, and you're going to link the oxygen and the carbon bond here. In the presence of pyridine, what you're going to get is a anhydride. Okay, anhydride here. Okay, and HCl going to be removed as the byproduct. Now we're going to look into the reaction number 4 of the B. Okay, so the carboxylic acid will react with ammonia or amine in order to form amide. Okay, so carboxylic acid can react with ammonia in order to form amide. So this is known as the primary amide because the nitrogen here is attached with one alkyl group. And the byproduct here gonna be water because one hydrogen here gonna be removed with the OH here. So the byproduct gonna be water. Similarly, if you have the primary amine here, so because one hydrogen is substituted with alkyl group, so it's gonna be a primary amine. So when it is reacted, one of the hydrogen here gonna be removed with OH. So this gonna produce water, and what's balance is NHR. Okay, so what we're gonna get is a secondary amide because this nitrogen here gonna attach with one and another one here. So it's gonna be secondary amide, and the byproduct gonna be water. The next one is we have a secondary amine. So it's gonna be like NRRH. Okay, if ammonia, it's gonna be NHH. Okay, so since we are using two alkyl group, so it is known as secondary amine. Okay, so when the secondary amine react with a carboxylic acid, OH and hydrogen here gonna be removed in order to produce water. So what's left is NR2. Okay, and the byproduct gonna be water. And here gonna be tertiary amide because N gonna attach with 1, 2, and 3. Okay. So now let us look into the example. Let's say if we have the ClCH2C double bond OH react with ammonia here. So what we're going to do is we're going to remove OH and hydrogen from here. And the NH2 going to link to this carbon here. Okay, so this is going to produce a primary amide, also known as the 2-chloromethanamide. Next, we have a benzoic acid react with the ammonia. So the same thing, OH and hydrogen gonna be removed, and then this is going to link with NH2. Okay, and this is known as the benzamide, which is also a primary amide, and the byproduct here going to be water. So now if you have another carboxylic acid here, and then you react with a primary amine, okay, because it's attached with one alkyl group. So what you're going to do is one hydrogen is removed and another hydrox OH group is removed from the carboxylic acid. So C and bond gonna link together, and this gonna produce a secondary amide here because the nitrogen is attached with one and two alkyl groups. So it's gonna be secondary amide. Okay. Now for the C type of the reaction, which is the reduction with the lithium aluminium hydride. So reduction of the carboxylic acid to alcohol is done via the reaction using the lithium aluminium hydride, which is LiAlH4, and this process must followed with hydrolysis. Okay, followed with H2O, H plus, or H3O plus. Okay, so please ensure that you write this one. Okay, so let's say if you have a carboxylic acid and then you want to reduce it to alcohol, so what you're going to do is you're going to react that with lithium aluminum hydride followed by hydrolysis, and this is going to produce a primary alcohol. Okay, and the reduction process means that it's going to lose oxygen and it's going to replace that with two hydrogen, so H and H here, and that is why you got an alcohol. Okay, now let us look into the example here. So let's say if you have the ethanoic acid, when it undergo reduction with lithium aluminum hydride at followed by hydrolysis, what you're going to produce is the primary alcohol, which is the ethanol. This one is ethanoic acid. Okay, and this one is a cyclohexane carboxylic acid. When it undergo reduction followed by hydrolysis, what you're going to produce is a CH2OH, which is a type of alcohol attached with the cyclohexane here. Okay, so it's going to be cyclohexane methanol. Okay, now we're going to look into the reducing property of the methanoic acid. So basically we have done with all the 7 reactions just now, which is A, B, and C. Now we're going to look into the reducing properties of the methanoic acid. So methanoic acid is basically the first member of the carboxylic acid homologous series. So this is the structure of methanoic acid because it have one carbon, double bond O, OH, and hydrogen here. So what's so special about methanoic acid is that it will gonna have two functional group. It has the carboxyl functional group. It also have a carbonyl functional group. Hence, it shows the properties of the carboxylic acid and aldehyde. So as what you can see here, C double bond OH, it shows a carboxyl group properties. C double bond OH here shows a aldehyde properties or the carbonyl group. Okay, so carbonyl attached with hydrogen, then it is known as aldehyde. Okay, so the methanoic acid is very special because it have an aldehyde properties as well as the carboxyl group properties. So it's going to show the reducing properties in reaction with hot acidified KMnO4, K2Cr2O7 as well as using the tolerance reagent. So let's look into the reaction of the methanoic acid with the KMnO4. So methanoic acid will react with KMnO4 at acidic condition at high temperature, and this is going to produce carbon dioxide as well as water, and the precipitate going to be formed, which is the manganese dioxide, which is the brown precipitate. Okay, at the same time the methanoic acid can react with dipotassium chromate. Okay, at high temperature and at acidic condition, what they're going to produce is the same product, which is carbon dioxide and water, but the ions from here is Cr3 plus, which is green solution in color. So first they are orange, but now they are turning into green solution. Okay, so this shows that the methanoic acid can be oxidized, which shows that it has the aldehyde properties. At the same time, the methanoic acid can shows its aldehyde properties when it reacts with the Tollens reagent, because you know that Tollens reagent is used to distinguish between aldehyde and ketone or any other any other organic compound. So when there is a aldehyde, it's going to give a positive result. So if it is positive, it's going to give a silver mirror, right? So methanoic acid react with the argentum NH3 plus at basic condition. What we're going to get is carbon dioxide, water, and argentum solid. So the argentum solid here will shows a silver mirror test. Okay, so you're going to have a silver mirror properties or observation that you can see, and hence this shows that the methanoic acid is a aldehyde as well as the carboxyl group, because it can undergo 7 type of reaction as shown in the earlier slide. Okay, and these are the chemical properties that you have underlooked just now, which is 7 reaction split into A, B, and C. Okay, so I think that's all for today's video. See you again some other time. Bye.